Today is about the chemistry measurements: length, mass, volume, and temperature. Measurement might seem like a no-brainer, but in science, your tools actually decide how much information you're allowed to report. Let's start with length using a rectangle and two different rulers. Ruler A has labeled the centimeters as the unit. 1, 2, 3, and 4 are centimeters, but the smallest markings in millimeter, or 0.1 centimeters. To get a good reading, we line up the left side of our rectangle with the 0 mark and look at where the right side ends. The rectangle clearly passes the 3.6 centimeters mark. Those two digits 3 and 6 are 100% certain because they are literally printed on the ruler. They're called certain digits. Note that the digit at the end always has the smallest marking, millimeter, on the ruler. 6 millimeters in this case. But look closer. The edge sits somewhere between 3.6 and 3.7. To my eye, it looks exactly halfway, so I'd guesstimate one last digit as 5 or 0.05. Combining with 3.6, I'd report 3.65 centimeters. Note that 5 is an uncertain digit. It is a guess. If you think it's a little shorter, however, you might say 4 as the last uncertain digit, giving you the result 3.64 centimeters, or your lab partner might see 6 as the last digit, then reporting 3.66 centimeters. All three of those answers are correct. They're all acceptable. In chemistry, we always estimate one last digit, and only one. And those certain digits, 3 and 6, plus that one uncertain guesstimate, 5, are what we call significant figures. So there are 3 significant figures in this measured number. In summary, the measurement steps are: 1. Find out the unit and smallest markings in the measuring device. 2. Read certain digits at the last solid line the object overlaps. 3. Estimate one last digit, the uncertain one. 4. Report the measured number. It can be different depending on who did it. Don't get greedy though. You can't report 3.652. That's 2 guesses, and we only get one estimate. If you just report 3.6, you're leaving out information. You must add an estimate after the certain digits. Now let's look at the same rectangle with ruler B. This ruler only has the smallest markings for whole centimeters: 1, 2, 3, 4. The edge passes the mark 3. That is the only certain digit this time. Last digit, the guess is about 5. Again, you may guess 4 or 6, all acceptable. Then we report 3.5 centimeters. Now notice the difference? Ruler A gave us 3.65 centimeters, 3 significant figures. Ruler B gave us 3.5 centimeters, 2 significant figures. The better the tool, the more significant your data becomes. More significant figures mean a more precise measurement. Sometimes the edge is right on the marking line. That trips everyone up. Let's say the edge of your object lands exactly on the 3.2 mark on ruler A. Most people just want to write 3.2. Don't do it. If you write 3.2, you're telling that your ruler is as basic as ruler B. Let's do it correctly. 3.2 centimeters are the certain digits though. The last digit is 0 because the edge is right on the line. Remember, you must get the last digit in addition to the certain one's 3.2. Now you can report the measured number as 3.20 centimeters. Well, you might think that the edge slightly passes 3.2 centimeters. Then your last digit can be 1. You may report 3.21 centimeters. Or, the edge looks a bit shorter than 3.2 centimeters to your eye. Then the certain digits become 3.1 centimeters. The last digit, say 9. You may report 3.19 centimeters. Once you understand how to measure length, you can apply the same principles to other physical quantities like volume, temperature, and mass. The key is to identify the certain digits and then estimate one uncertain digit. In a chemistry lab, scientists commonly use graduated cylinders to measure liquid volume. For a cylinder with a capacity of 100 milliliters shown in the picture, this is the main marking 40 milliliters, 50, and 70, as indicated by red arrows. The smallest markings are milliliters by green, the circle between 80 and 90 milliliters. When you pour liquid into the cylinder, the surface forms a curve known as a meniscus. It is more clear in the expanded picture. To ensure accuracy, you must read the volume at the very bottom of this curve. The liquid passes the 53 milliliters mark, but does not reach 54 milliliters. So the certain digits are 53. The level looks to be 7/10 of the way up. The last digit is estimated to be 0.7. Combining these, we report 53.7 milliliters as the measured volume, 3 significant figures. While another observer might estimate 53.6 milliliters or 53.8 milliliters, the final digit always represents that inherent uncertainty. Measuring temperature follows the exact same logic in the volume measurement by graduated cylinder. When using a standard thermometer, you first identify the unit and smallest scale increment. The thermometer shown in the picture has 2 units, Celsius on the left side and Fahrenheit on the right. While Celsius has 1 degree smallest markings, Fahrenheit has 2 degrees smallest markings. For Celsius, the red liquid level passes above the mark 37, which are then the certain digits. I'd guess the last digit is 9 because it is just below the next line at 38. The result is 37.9 degrees Celsius. As for Fahrenheit, the liquid looks right on the line at the 100 mark. 100 are the certain digits and the last digit is 0 since it is on the line. The final reading is 100.0 degrees Fahrenheit. When using an analog scale for mass measurement, such as a dial scale, you apply the same estimation rule. The scale shows that the unit is kilogram, 1 through 5 kilograms in the scale, and the smallest markings represent 0.1 kilograms. When you load the weight, the needle points passing the marking line 3.7 mark, you simply write 3.7 as the certain digits. And you must include the estimated digit, say 2. The final measured mass is recorded as 3.72 kilograms. In modern labs, digital displays are often preferred for their ease of use. You can read the numbers directly from the screen, such as a digital thermometer showing 23.5 degrees Celsius. However, the principles of uncertainty still apply. In a digital reading, the device performs the estimation of the last digit for you, the 5 in this case. That is the uncertain digit, while the digits preceding it, 2 and 3, are the certain digits. This reading contains 3 significant figures, reminding us that even digital measurements have a limit to their precision.